powerful platform, that is BYJU'S Exam Prep. And guys, we are here with the next subject, that is theory of machines. We have already completed strength of material, fluid mechanics and industrial engineering. Now this session is related to the theory of machines. Please tell me guys, am I properly audible and visible to all of you or not? Then we are starting the session. Nikhil, namaskar dear. So guys, today's session is related to simple mechanism and their velocity and acceleration analysis. Okay. So today we are not only going to discuss only simple mechanism, along with that their velocity and acceleration analysis. So these two topics will be covered today. Ashrit, hi dear. And guys, as you know, in this series, whenever we are going to start, we are going with learn through questions. Okay. So whatever we are going to learn, that will be through the questions. So whenever I will be going for any question, so in that question I will be telling you the concept which is required, and similar questions you are going to have in the examination. So guys, do like and share the session so that other student can also join fast, so that we can start the session. Midun, good evening. Piyush ji, good evening. Teju, hello dear. So guys, let us start the session without wasting the time. So this is some introduction about myself. I am having around 10 plus years of experience, and today's subject is theory of machines. This we have already completed. Okay. So one by one we will be covering every subject. Surendra, good evening bhai. Let us continue guys. So guys, this is about this monsoon free course. Vishnu, hi dear. So you know guys, this course is going on at 6 PM daily for you guys, where we are completing the syllabus using learning through technique, learning through questions, because with that only you can cover all the types of question, and that will help you in the exam. Sachin, good evening dear. Yes. So guys, let us move further. So this is a workshop by Abhinav Negi sir. It would be live on 12th July 8 PM. Okay. So you can register if you are interested in this workshop. Now we are starting the question guys. This is the first question in front of you. Bhanu, good evening dear. So this is the first question in front of you guys. This is the only questions which I have taken an easy one. Okay. Other questions are definitely conceptual based, but they are of new types. Okay. So this is the first question. Let us see how many of you give the right answer. Naveen, hi dear. So do share the session guys, so that others also join. So guys, in this question they are asking you about degrees of freedom. So guys, I have covered all the types of questions. So attending this session, you are going to learn all the types. Yes, Ashrit is saying 1, Bhanu Teja is saying 1, Teju is saying 1. Okay, what about others? Vishnu, Nikhil. Yes, Surendra Singh is saying D. Very good dear. What about others? What about others? Midun is saying D. Bahut hi badhiya. Nikhil is also saying D. So guys, as per your answer, D is going to be the correct option, and yes, it is a correct option. Very good, Piyush ji. So guys, if you see this question properly, if I go with the formula of degree of freedom, you know, formula for degree of freedom is given as 3 into L minus 1 minus 2J minus H. So this is the formula to find out degrees of freedom. Here L is the number of links, J is the number of binary joint, H is the number of higher pairs. Okay. So when we are going to find out the degrees of freedom, very good Sachin. When we are going to find out the degrees of freedom, first of all, you need to find out the number of links. So this is link number 1, this is link number 2, this is link number 1, then link number 3, link number 1, link number 4. And this complete actually is going to be one link. So this is link number 5. Okay. So this is a double parallelogram linkage, is also given the name of Kurzbach paradox. So my dear, if you see the number of links are 5. Okay. The number of joints, if you find out, then there is 1 joint, 2 joint, 3 joint, 4 joint, 5 joint, 6 joint. All are binary. Binary means only 2 links are connected at that joint. So joints are 6. Higher pair is not present. If you will apply the formula, my dear, the answer will be coming out to be 3 into L is 5. 5 minus 1 minus 2 joint is 6. Okay, higher pair is not there. So you will be getting 12 minus 12, 0. So you might be saying it is a oops moment. Sir, answer is coming 0. It should be CYD. So dear, I would like to tell you that this is an exception. You know, it is not following the Kurzbach equation and also not following the modified Kurzbach equation. Because if also you will write minus FR, there is no redundant motion present in this mechanism. So my dear, actually this is an assumption, this is an exception, because my dear, whenever we are talking about double parallelogram linkage, this is used in joining two wheels, three wheels. Like if you are joining this wheel and this wheel, you will be joining them with this type of mechanism. And you know my dear, in this you will be getting the motion. If this will be rotating, this will be rotating, this will be rotating. So degree of freedom should be 1, not 0. So my dear, if that is the case, where we are actually mistaking, because it is an exception. So my dear, for such cases, if you see link number 3, this link is a redundant link. What is the concept of redundant link? My dear, if presence or absence of a link is not going to affect much the relative motion, such links are said to be redundant link. So if this link is not present, then also it will be rotating clockwise, it will also be rotating clockwise. Okay, so relative motion between input and output is not going to be affected with the presence or absence of this link, and such links are said to be the redundant link. So my dear, then Kurzbach said that if you find any such link in the mechanism, complete the calculation by removing such kind of link. Do not count such type of link. So my dear, we will be removing this link, and now we will be having the mechanism like this. After removal of that, you will be getting the mechanism like this. It will become parallelogram. So it is 1, 2, 3, 4 and 1. Now degree of freedom is 3. Number of link are 4 minus 1 minus 2. Joint is 1, 2, 3 and 4. All are binary. So it is 4 minus, there is no higher pair, no redundant motion. You will get the answer to be 1. So guys, this is how you can find out the answer for such question. So answer is going to be D. So you can see guys, if the same link would be present in some other configuration, how? If this would be present like this. This is fixed link, this is one link, this is other link, and this link would be present like this. Then my dear, presence or absence of this link would become important. Now if this link is present like this, it will not be allowing this motion. So presence and absence are making or creating the difference. Then this is not a redundant link. So in this case, it is not a redundant link. So my dear, if you get this, then the degree of freedom will be 0 only. So guys, that is why we have given the name to this series as learn through question, because we are not only dealing with those questions, but we are also telling you that if question will be rotated to this position, then what you have to do. So that is learn through question. We are learning multiple concepts with the same problem. Kaviraj, very good dear. Very good Teju. So let us move to question number 2 now. This is easy question. Slowly level will be increasing. Okay. Yes. Wonderful guys. Wonderful guys. So like and share the session guys, so that other student also reach here. What would be the answer for this? Degree of freedom is equals to, degree of freedom is equals to 6 minus number of restraint, 4 minus number of restraint, 2 minus number of restraint, or 1 minus number of restraints. Yes, very good. Manas, Teju, Surendra, Nikhil, Pranjal, Bhanu, Jishnu, very good Jishnu, Piyush ji, very good guys. Kaviraj, the answer for this is A. Okay guys, so you know for 3 dimension, the degree of freedom is written as 6 minus R. You know the maximum degree of freedom are 6 in 3 dimension. So it would be 6 minus R. R is the number of restraint. And for 2D, it would be 3 minus R. So guys, you can see for 3D, it is 6 minus R. For 2D, it is 3 minus R. So guys, if it is a MCQ and you get both in option, then you will be going for 6 minus R. So A is going to be the right answer. Okay, if it is MSQ, then it may have both the option for degree of freedom. If they are not mentioning it is for 3D or 2D, okay, then it may become a MSQ. Yes, is it clear guys? Everybody is getting it? Please tell me that. Then we are moving to the next question. Yes. Question number 3. Now comes the numerical. Very good, Sachin, बहुत बढ़िया. Now comes the numerical. As I already told you, slowly we are moving to good level questions. Okay, one by one. Yes. So guys, just like and share the session. Kaviraj, good. So this question is the length of the fixed link of a crank and slotted lever mechanism is 250 mm and that of crank is 100 mm. Those who don't know about the mechanism, I am making it. This is the fixed link, okay, and with the fixed link we have this kind of configuration. Okay guys, so we have like this, and you will be having a slotted bar like this, where you will be having, yes, the crank. So guys, this is O dash, A, B. This is starting from B1, B2. This is A1, A2. So you need to answer it, guys. Everybody. So guys, they are saying that this L is 250 mm. Don't worry, those who don't know about this, for them also it is going to be useful. I will be telling you how to solve. Very good, Bhavya, I was waiting for you. Very good, Bhavya have answered it 1.7. Teju is also answering it as B. Very good. What about others, guys? Piyush ji is answering B. Okay, very good, guys. Bahut badhiya. Yes. Pranjal is saying B. Bahut badhiya. Bahut hi badhiya. What about others? So guys, this type of questions are coming in GATE from last 33 years. Kaviraj, very good. So answer is B, guys. You know, this OO dash is the length of connecting rod. Crank is this OA. This is R, which is 100 mm. So this is said to be OA. So my dear, whenever this motion is going to happen, very good, Jishnu, bahut badhiya, Bhanu. I told you guys this angle is alpha actually, and this angle is going to be beta. Okay, so you know one thing, that alpha plus beta is 360 degree. So my dear, whenever you find a question on crank and slotted lever mechanism, how you shall move on, I am telling you, your first step for such question will be this one. You will be writing cos alpha by 2. This we have discussed in the discussion of the derivations. Cos alpha by 2 is R by L. This is going to be your first step for the question. You know, R is given as 100 mm, L is given as 250 mm. Is it correct? 100 and 250 is correct? Yes. So guys, when you will be putting this 100 and 250 value, then my dear, you will be getting alpha by 2 value. From this you will be getting alpha. And you know my dear, beta plus alpha is 360. You will be getting the value of beta. And beta by alpha is the quick return ratio, which is the question asked from you. So my dear, you must be getting alpha as 227.32 degrees. Sorry, not 227. What you are getting, please tell me. This is the value of beta you would be getting. Is it coming 127? What is the value of alpha? Very good, Divyansh, bahut badhiya. What you are getting as alpha, tell me the value. 132.8. Yes, 132.8 is the alpha value. Beta will be 227.2. So when you will be finding out this ratio, 227.2 divided by 132.8, the answer will be 1.709. So answer is nearly 1.7. Okay, so if you see the options given to us, very good, Piyush, answer is going to be 1.7. Let us move to question number 4 on the same data, my dear. Next question is on the same data. So guys, just like and share the session so that other student also join it. Yes, this is the same data given, and here they are saying that R is 100 mm. Length of connecting rod is 250 mm. And there is something known as slotted bar. So this length is capital L, which is given as 450. So capital L is 450. So you need to find out the stroke length. Stroke length formula is 2 times L R by L. apply the formula, get the answer. So those who are going for this subject for the first time, for them I am giving you the formulas, and these are the types of question you are going to see in the paper, guys. So nothing will be changed other than the data. Okay, कुछ नहीं बदलेगा डेटा के सिवाय. वंडरफुल गाइस, बहुत ही बढ़िया भव्या, बहुत ही बढ़िया भव्या, बहुत ही बढ़िया. चलिए, सो गाइस, very good. So answer will be coming out to be 360 mm. So guys, you just need to put the value and get the answer. So you will say 2 times into 450 into 100 by 250. So you will be getting 0 will get cancel out, 25 4 ja. Okay, 8 into 45 is 360 mm. So very good guys. Question number 5 in front of you. This is from velocity analysis now. Very good Jishnu, very good. बहुत बढ़िया. Nikhil. Now the question is from velocity analysis. Yes, Sachin. I feel you got your mistake. Now solve this question, guys. This is from eye center approach, instantaneous center approach. Yes. So today we are covering simple mechanism, velocity and acceleration analysis. Tomorrow we are having the topics kinematic and dynamic analysis of single slider crank mechanism plus flywheel topic. Okay. So tomorrow be ready for kinematic and dynamic analysis plus flywheel. Questions will be other than GATE for sure. Okay. So be ready. Yes, Piyush, if you have a question related to theory, ask me separately after the class. You have my number. Okay, if it is related to the questions going on, then you can ask here. Okay, otherwise after the classes you can call me if particular some other doubt is there. Fine. बहुत बढ़िया guys. Piyush ji, that we have discussed. Okay, if you are asking me, I will be discussing it at the end, but I already have told you in the classes that because whenever the transmission angle is deviating more than the 90 degree, like if it is going to be deviated from 90 degree, then output torque is getting reduced. So if transmission angle would be having more deviation, then the rotation of output link will become difficult. This we have proved in the class. So as I said, if you have doubt, for you I will be discussing at the end. Okay. So Jishnu is saying D, Teju is saying D, Bhavya is saying A. Okay. What about others? What about others? Okay. So guys, I am giving you the hint for this question. बहुत ही बढ़िया. I am going to give you the hint for this question, my dear. This is question from eye center approach. Okay. So dear, you can see the velocity direction of point A is given like this. To find out eye center, you need to sit perpendicular to the direction of velocity. Obviously, when this point will be going up, this point will be going to the left hand side. So if you sit perpendicular to this, this will be the line. So both the lines are cutting at this point. So this point will be acting like eye center of rotation. So this point will be acting as a center about which this complete link looks like to be in pure rotation for that particular instant. So my dear, you can write velocity of A equals to AI into omega of the rotating link. You know that velocity of B can be written as BI. This is from the concept V is equals to R omega. Like if there is some circle and you want to find out the velocity of this point, this is center C. Then you know if this is point A, you will be saying if this is R and it is rotating with omega, then velocity is going to be R omega. So the same principle we are applying here. I is the center, A is the point on the body, and this body is having the angular velocity of omega AB. So my dear, you know velocity of A is known to us. You need to find out velocity of B. So you can just divide VB by VA. Dividing VB by VA will give you BI by AI. Omega AB will get cancelled out to each other. So BI by AI, you can see BI by AI. Okay. And for that, my dear, they have given this distance as 0.9 meter. This distance is 0.9 meter. And they have also mentioned, I feel, 1.5 meter is the length of link. So this is 1.5. So my dear, you know that if this is the triangle and if let us say this angle is going to be theta, then 0.9, you know this is 0.9, this angle is theta. If you see this triangle, this is 0.9, this is 1.5 and this is theta. You can say sine theta is perpendicular upon hypotenuse 0.9 by 1.5. So from here you can find out theta very easily. Once you get this theta, my dear, you can find out this. This is 90 minus theta. So you can write tangent 90 minus theta. This is going to be, okay, sorry, I feel I have written it slightly wrong. You can see one thing, if this angle is 90 minus theta, this is 90, this will be theta. Sorry, this is 90, this will be theta. Okay, I am once again writing, don't worry. This is 90, this is theta. So we can write tangent theta as perpendicular upon base. So BI upon AI. So theta you will be calculating from here, put it as tangent theta. You will be getting VB to be VA tangent theta. Putting the value of theta, the answer will be 2.25 meter per second. Is it clear for everyone? Yes, Pranjal, we can go like that also. Yes, Pythagoras se bhi ja sakte hain. Because you know that this distance is known, this distance is known. You can find out this by Pythagoras also. But every time they are not giving you all the distances. Why I have gone through this way? Because generally they are not going to give you two dimensions. They will give you length and angle is mentioned. So I want to prepare you for all the situations. Is it clear? So answer is D. Okay, Bhavya, very good. Bahut hi badhiya. Kaviraj, you got it? Yes. So the answer is D for this. Question number 6. Once again from I Center. Very good, Kaviraj. So question number 6, guys. Yes, Nikhil, Bhavya, Pranjal, Kaviraj, Ashrit, Teju, Bhanu, Piyush ji, Surendra. Yes, all of you guys. Sachin, Jishnu, Anurag, good evening, dear. Anurag, good evening, dear. Pawan Kalyan, very good. Naveen, bahut hi badhiya. So Jishnu, Piyush, Pawan and Naveen have given the answer as B. Midun is saying D. Pranjal is saying B. Yes. Dear, this is the case of pure rolling motion. This is the case of pure rolling motion. And whenever the motion is pure rolling, such kind of pairs comes under the category of which pair? Rolling pair. And in case of the rolling pair, eye center lies at the point of contact. And I feel everybody from your side would be clear that B is the point of contact. So B will be acting like the eye center for this case. The answer is B for this. Very good, guys. Bahut hi shandar. Let us move to the next question. Wonderful, guys. This is a new type of question. This have never come in the GATE exam. This is new. Okay. So whatever we have discussed till now, these types of questions have already been there. But this type of question have not been there in the GATE. Very good. Bhanu Teja, at infinity, the answer will be for sliding pair, not for the rolling pair. Okay. Very good, guys. Bahut hi badhiya. So consider a 4-bar mechanism as shown in the figure. For data given in the figure, the velocity of C is given by. Here the best thing is they have made the eye center. This is the eye center and distances are also given to you. So you know one thing, that if this is point B, this is point C, you need to find out the velocity of C. So you know that I'm giving you hint. Velocity of B is AB into omega AB, and also it can be written as BI into omega BC. And my dear, similarly VC can be written as CI into omega AB. Hint is there in front of you. Solve it. Get the answer. Yes. Jishnu, Bhavya, Teju, Bhanu, Ashrit, Pranjal, Midun, Naveen, Pawan. बहुत ही शानदार गाइस, मजा ही आ गया, बहुत ही बढ़िया. Solve this question guys. We are having 30 plus question, around 35 questions I am having. Okay, and they all are new questions, never discussed in the previous YouTube sessions or in the classes. Naveen Dola, very good. Okay, Ramesh Mon, hi dear, how are you? Okay, so answer Naveen have given. What about others? Okay, Manas, very good. Manas is saying A. Guys, do like and share the session. Okay, Sachin, if any doubt you find in the question, do ask at the same time. I will help you. Don't worry. Okay, so if doubts are coming, there is no issue. Whenever I give explanation, after that, if any doubt is coming into your mind, do ask here. I will be going for the complete explanation again. Okay. Jishnu is saying answer is A. Bahut badhiya. What about others? Wonderful guys. Ramesh Mohan, what would be the answer, dear? Bhanu, Teju, Bhavya, waiting for your answer. Ashrit, Pawan is saying A. Bahut badhiya. Is there exam this week also? Yes, Jishnu, we will have on this Sunday, 6 p.m. you have the quiz once again. Okay. Surendra Singh is giving the answer as A. Piyush ji A. Bahut badhiya. Teju A. Okay. So dear, if you see how we are solving it properly, my dear, point B is common at link AB and BC. So we can find out velocity of B by taking it on AB and taking it on BC. First, let us consider point B on AB. You know, velocity is given as r omega if the body is in circular motion. So this AB is in rotation or in circular motion? In rotation about A. So if it is rotating about A, AB into omega of AB will be the velocity of B. So my dear, velocity of B with respect to A can be written as AB means 25 centimeters into omega 2. So this is going to be 50 centimeters per second. Okay, this is going to be the velocity of B with respect to A. And my dear, velocity of B considering B on BC can be written as, this BC link is in pure rotation about the I center. So you can write velocity of BI. This is going to be, this is BI into omega BC. And you know, this is going to be 50 because velocity of B cannot be different. Velocity of one point cannot be two. Only one velocity will be there with the one point. So that is why they are going to be equal. Then my dear, velocity of CI can be written as 20 into omega BC. So that we need to find out. Just take the ratio. You will be getting the answer to be 1/3 meter per second. So you will get velocity of CI is 1/3 meter per second. Okay, mind it, this is centimeter per second. So you need to divide it with 100 to get it in meter per second. बहुत ही बढ़िया guys, मजा ही आ गया. So answer for this is A finally. Moving to question number 8. Moving to question number 8. This is to tell you the concept of relative velocity. Very good, Bhavya. In the 4-bar mechanism given below, the magnitude of absolute angular velocity of link 2, omega 2 is 15. and omega 3 is 11. Yes, guys. I would like to tell you, okay, after this hint, this question is nothing. Omega 23 is defined as omega 2 minus omega 3. Yes. Wonderful, guys. Bahut hi badhiya. So guys, today velocity acceleration analysis of simple mechanism. Tomorrow flywheel and kinematic dynamic analysis of single slider crank mechanism. Day after tomorrow we will be going for balancing and vibration. After that we will have cam, governor and gyroscope. Then last class will be gear and gear train on Saturday. Sunday you have a quiz on the app. Okay. Yes, this is the schedule. Fine. Surendra Singh C, Midun C, Naveen C, Ashrit C, Piyush C. Sir, doubt is how to start these type of question. Dear, for this type of question you are asking or the last type? I am telling you the complete procedure. In that way only you need to go with. If you are clear with the concept, then whatever I am showing you is how we are starting the question. Okay, like if you see the previous question, you want to find out velocity of C which is on BC and velocity of AB is given. So you will start from the given data. From A to B you will go and then B to C you will go. So that's why I started with VB, then found out VC. So always start from the given data and then find out whatever is asked. Naveen, tomorrow is flywheel and kinematic and dynamic analysis of single slider crank mechanism. Tomorrow is kinematic dynamic analysis of single slider crank mechanism plus flywheel. Okay, so tomorrow is that topic. So you know it is given as for link 2 is 15 radian per second. For third it is given as 11 radian per second. They are absolute. So 4 radian per second will be the answer. So answer is C. Okay, so this is how we can solve it. Next question, guys, question number 9. So I have taken some theory questions also because in 1 mark in theory of machines many times these questions have been asked and I don't want to put any side unturned. So I am covering theory questions, numerical questions, and guys from tomorrow's session I am going to add MSQ also. Be ready for that challenge. From tomorrow's session MSQ will also be there in the class. So we are making this series as perfect as it is possible. Surendra Singh, when they are giving absolute velocity, then they are giving you the actual velocity. You need not to think about that. Okay, when they are giving that, then there is no need to think. If they would be saying relative velocity, then you need to think about that. Okay. Okay, Surendra Singh. When they are saying it is absolute, you need not to think. You are not going to calculate because they have given. But if they say that it is absolute, it is relative, then you need to think over it. Fine. Jishnu is saying A, Teju is saying A. What about others? So, point P and Q lie on a rigid link. This is a rigid link. This is point P. This is point Q. So my dear, they are saying that link which have rotational moment about its I center of rotation O, the magnitude and direction of linear velocity of the point are given as. So obviously you will be writing the velocity of P as O is the I center. So OP into omega. Velocity of Q will be OQ into omega. This we have just seen. And if you see velocity is perpendicular to OP, velocity is perpendicular to OQ, because you know whenever you are going to have I center, so you know direction of velocity of P will always be perpendicular to the I center. You know one thing also. Okay. So like we have seen, I am making another diagram, don't worry, which will be making you clear all the things. Okay. Let us say there is some link PQ. Okay. So if P point is moving in this direction, Q point is moving in this direction. So you know this is going to be direction perpendicular to the motion. This is direction perpendicular to the motion. Then my dear, you know this is going to be the point I center. They are saying it as O point. So you can write velocity of P as what? OP into PQ. OP into omega PQ. Omega PQ. And what will be VQ? VQ will be OQ into omega PQ. This is what you are going to write. So the same thing they are mentioning in the question. So answer for this is going to be A. Okay. They are writing here parallel, so it is wrong. They are writing here perpendicular to PQ, so it is wrong. They are saying none of these. When A is the answer, D cannot be. Let us move to the next question, guys. Sir, I center coming sitting to direction of velocity. I center is coming by sitting perpendicular to the direction of velocity, because velocity direction and radius are perpendicular to each other. I discussed that in a great detail in the class, if you remember. Yes, question number 10. 2 points A and B located along the radius of a wheel. Consider a wheel. Consider a wheel. This is the radius of the wheel. They are saying have velocity of 80 and 140 meter per second. So consider 2 points. One is A, other is B. Okay. Yes, one is A, other is B. Let us say this is B. B may be at the end, you can consider there also. This is B. So if this is rotating like this, velocity of A is this, velocity of B is this. They are saying the radius of the wheel is 700 mm. What will be the distance between AB? You need to find out this distance. Try to solve it. Let us see how many give the right answer. Piyush ji, diagram is not given, so you will be going as per your thinking. Okay. So they have not mentioned the diagram. So you can write velocity of A is OA into omega. Velocity of B is OB into omega. So OA into omega is 80 meter per second. And this is 140 meter per second. And they have given AB. So you can write it as OA plus AB. OA is already given to us. AB is already given to us. So OA plus 700. Okay. Sorry, OB is given to us as 700. Okay. Take as the value given and then find out. Yes. Very good. Bhavya is saying 300. Bhavya is saying 300. Very good. Piyush ji 300. Nikhil 300. Dear, diagram is not required. You can take in any way, you will get the right answer only. They are saying that what is the distance between A and B, that you need to find out. Okay, Nikhil, no issues. अनुराग सर, ये क्या लिखा है अनुराग आपने? 7WL कैनेडी थ्योरम सही होगा. Pawan is saying D, Teju is saying D. Okay guys, so I am telling you how to solve it. They are saying velocity of A is OA into omega. It is 80. Then they are saying velocity of B as OB into omega. It is 140. So my dear, we are just doing one thing. OA, OB is known to us. OB is 700. So you can find out omega is 140 by 700. This OB is 700 mm, but that is meter per second. So meter per second and mm. Then my dear, you need to find out the distance AB. And you know that VA is OA into omega is 140 divided by 700 is equals to this is 80. You will be finding out from here OA will be coming out to be 400. So my dear, you know that you can write OB is OA plus AB. So AB will be coming out to be 300 mm. So this is how you can solve this question, guys. So the answer for this is D, 300. Very good, guys. Arey bhai Piyush, whenever they are giving that one link is rotating, AB is the circle radius, so it will be on the circle only. Because they are saying circle is having the radius, and that radius they are defining that B cannot be outside. If such kind of thing happen, they will mention it. Otherwise, how you can solve it? Yes, Jishnu, OB is 700 because they have mentioned the radius 700. Dear, actually, whenever you are having this kind of thing, okay, you are having how I have taken OB to be 700. So dear, yes, you can feel that that should be mentioned that it is radius. So I have assumed it, no doubt about that. But this type of question whenever comes, either figure should be there. Okay, like in books, whenever this question you see the figure is given. So that is, yes, you are correct. Okay, so I am showing you the previous question again. In this question, okay, sorry guys, they have mentioned shown in the figure. So then the figure is missed, okay, sorry. They have written in the figure, then the figure is missed. I understood your doubt, okay, that is I feel typist forget to put the figure there. Sorry for that, okay. That is typing error. Because they have written but figure was not there, so it is typing error, don't worry. So as I have solved that question, so I remember the figure in my mind, okay. So a rod of length 1 meter is sliding in a corner as shown in the figure. At an instant when rod makes an angle of 60 degrees with horizontal plane, the velocity of point B on the rod is √3, the angular velocity of the rod at this instant. Yes. This is very easy question. Solve it, guys. Very good. Nikhil, Kaviraj, Piyush, Pawan, Midun, Teju, Pranjal, Bhavya, Habhi Bhanu, Surendra Singh. Surendra Singh. Okay, you also remember. Very good, Teju. Yes. So that was missed. That is typing error. Sorry guys for that. Okay. Sometimes it happens. We all are humans. So human errors are always there. Ashrit, very good, dear. So dear, they are saying that this angle is 60 degrees. If this point is going down, this point will be going to the right. Sitting perpendicular to the direction of motion, sitting perpendicular to the direction of motion. This is point I. If this angle is 60, this is going to be 30. And they are saying this radius, this distance is 1 meter. So they are giving you already velocity of A, I. So velocity of A can be written as AI into omega AB. And velocity of B is BI into omega AB. So when this is known to us as 1, you need to find out this distance AI. Okay, if this angle is 30 degrees, you know this is unknown, this is known to us, use sine theta there. Okay, so you can write, my dear, sine theta is perpendicular upon hypotenuse. This is AB. Perpendicular is AI divided by AB. From here you can find out AI to be AB sine 30. Putting this, you will be getting omega to be 2 radians per second. They have given both velocities actually. Okay, very good guys. बहुत ही बढ़िया. Next question guys, question number 12. Okay. Okay, now we are coming to theorem of angular velocities. This question is from theorem of angular velocity. Solve it guys, solve it. अब आएगा मजा. कुछ और अच्छे क्वेश्चंस में we are entering. Till now they were all very basic question. Yes, Jishnu, Ashrit, Nikhil, Bhavya, Pranjal, Midun, Kaviraj, Pawan, Piyush, सुरेंद्र, भानु. मुझे आप सभी लोगों के नाम याद हो गए. आई रिमेंबर नाउ द नेम ऑफ एवरीवन. ओके, यस. So solve this question, guys. This is a very good question, and this type of question 2 to 3 times asked in GATE paper. So this is very, very important. So in this session we are covering all the types, my dear. So don't worry about that. And do like and share the session, guys. We are still left with 18 questions. Some are theory, some are numerical. So guys, do you want me to add MSQ now from tomorrow? Tomorrow I will try to add at least 3 MSQ, starting with 10%, then we'll reach to 30% MSQs. Okay, because this year MSQ were there. Very good. So solve it, guys. Great. Solve it, solve it, solve it. Nikhil is saying C. Very good. Very good, Nikhil. What about others? Jishnu. They are asking for a special configuration when link 2 will become horizontal. I will be solving it properly so that you can learn the complete approach. Okay? How to start with eye center approach. So only one student have given the answer till now. Bhavya, Teju. Okay, Bhanu. Piyush ji, very good. Bhavya, this was not expected. Okay. Yes. Fine. So I am telling you this question with the complete concept. What is theorem of angular velocity? Okay, we will start. So guys, whenever you find such kind of question, first of all, make the configuration they are talking about. And as this have already been asked in GATE, this type of question can come this year also, because 3 times already came. So let us see how to solve this. First of all, let us make the configuration they are asking. They are asking some configuration when this link will become horizontal, like this. This is the configuration they are talking about. When link number 2 will become horizontal. So A, B, C, D. Let us give the name first. This is A, B, C, D. This is link number 1, link number 2, link number 3, and link number 4. So my dear, whenever you will be making the configuration, what is the second step? Second step is you will tell me what are the number of links. What are the number of links? Can you tell me? Anybody? What are the number of links in this mechanism? I am telling you with complete procedure, learn through question. The number of links for this. Very good, Ramesh Mon. Number of links are 4. You know the formula for number of eye center. This is L into L minus 1 by 2. We will put the value of number of links as 4 into 4 minus 1 divided by 2. This will be coming out to be 6. 4 number of links, 6 eye centers. We will make all the eye center. You know, eye centers are denoted as 1 2, 1 3, 1 4, 2 3, 2 4 and 3 4. So these are the 6 eye centers, guys. Now out of these 6 eye center, you know, minimum 4 are known to us. Minimum 4 eye centers are known to us. So which are those eye centers? Why minimum 4? Because number of links are 4. So minimum number of eye center known equals to the number of links. So this eye center is I12. This eye center is 2 3. Because they are turning pair. In turning pair, point of contact, point of pin joint is the eye center. This is eye center 3 4. This is eye center 1 4. So we know 1 2, 2 3, 3 4 and 1 4. Now we will start from the first row and we will see which one is the first unknown. So my dear, first unknown is 1 3. First unknown is 1 3. So now you will be making a circle, and in this circle you will be making a polygon equals to the number of links. Polygon will be made up of the sides equals to number of links. There are 4 links. If with 4 links you will make a polygon that is quadrilateral. So we will make a quadrilateral. Yes, Teju, that's why I was saying 1 2 3 4. That's why I was saying monsoon course is very important for all of you. Okay. So in this you will be revising all the things with the questions. So this is 1 2 3 4. These dark line shows that these eye centers are known. 1 2 is known, 2 3 is known, 3 4 is known, 1 4 is known. You will be making the unknown with the dotted line. Unknown is 1 3, make it with the dotted line. So if you want to reach from 1 to 3 via dark lines, there are 2 paths. Going from 1 to 3, there are 2 paths. One path is 1 2, 2 3. Second path is 1 4, 4 3. So this is Kennedy theorem, which says that 1 3 will be lying at the intersection of 1 2 and 2 3. So the line joining 1 2 and 2 3 is this one. We will extend it to the both the sides. Line joining 1 2 and 2 3 will be extending to both the side. Then we will extend the line joining 1 4 and 4 3. So 1 4 and 4 3, this line will also be extended like this. So if eye center 1 3 is lying on the line joining these two and line joining these two, it means it will be lying at the intersection of these two lines. So 1 4 will become 1 3 also. So 1 4 will become 1 3 also, my dear. Is it clear? So guys, we got, dear, yes, similar question was there, but same question was not there. I have changed the data. So mark my hard work in that also. I have changed the data. Data is not same. Type is same. Okay. So my dear, now we will go for the second unknown. Second unknown is in the second line, that is 2 4. So when we will be going for this 2 4, for that once again there are 2 paths. The first part is 2 1 1 4. 2 1 1 4. Second path is 2 3 3 4. 2 3 3 4. Yes, Bhavya, aa gaya yaad. 2 1 1 4. So 2 1 1 4. 2 1 1 4. So we will be extending the line joining 2 1 and 1 4. Once again, this is the line. And then 2 3 and 3 4. 2 3 and 3 4 is this. So here you will be getting 2 3 will become 2 4 also. So we got all the eye centers now, my dear. Now we will be applying the theorem of angular velocity, which says that omega m I mn I1m omega n I mn I1n. So you know they were asking you what in the question? They were saying that, okay, I feel question is this one. They are saying that velocity of link 3 you need to find out, and velocity of link 2 they have already given to you. So you need to find out third velocity, velocity of second is given. So 2 is known, 3 needs to be find out. So this will become m, this will become n. So you will write omega 2 I23 I12 is omega 3 I23, I13. So guys, this is 500. I23, I12. I23, I12 is the link length 2. Link length 2. So it is given, this is AB. AB is 100. So you will put the value 100. Omega 3 you need to find out. I23, I13. I23, I13 is the AB plus AD. This is AB plus AD. So AB is 100. You need to, okay, CD is given to us. This is CD is given. BC is given. AD is given as 250. Just put the value. So it will be 100 plus 250. So guys, you will be getting omega 3 142.84 radians per second. Is it clear? बहुत बढ़िया जिष्णु. Surendra Singh, sir, here second possibility of figure AB can be between two fixed point. AB can be between two fixed point. Dear, उससे कोई फर्क नहीं पड़ेगा. सोल्व करने का तरीका will be this only. Okay? हाँ, but solve कर, yes, you are correct, but you can say whatever you are saying, but they have given the direction of rotation. They have given this direction of rotation. So horizontal will be in this side only. If they will give this way, then you will be making in that way. Okay? So very good doubt you have, Surendra. Pranjal, I completely solved but didn't show this AD length is given. Okay, Pranjal, that kind of mistake happens. So guys, that is the meaning of learn through question. I discuss the complete procedure in front of you. Okay? So guys, you just make the mood of study. And I am telling you, I will be giving you everything, whatever the way we are giving in the paid class. This is like that only. Okay? If you are very much serious student, I am always there to support you with all the things like handwritten notes, whatever the PDFs of the questions, whatever practice material you want, lectures which are available on the YouTube. I can recommend the playlist for theory part, whatever the doubts you have. Okay? For that, just join my Telegram channel, take my number and ask whatever the help you want. Next question. So after one difficult or lengthy question, now the question is easier one. And also I will tell you one thing, my dear, that whatever the type of question we are having, we will be covering all the types which are coming in GATE and some new types also. Anil, hi dear. If question is as given figure, is it possible? Jishnu, I already told you. In the previous question, if they are giving the direction in this way, then horizontal will become like this. Okay? Then this would be the diagram. Is it clear? Fine. Okay. Teju, put the value as per the given. I am mainly concerned with the concept here. Calculations you need to do. Next question. Magnitude of the linear velocity of any point on the kinematic link relative to the other point in the same link. So if this is the link, let us say this is point A, this is point B, and it is rotated with an angular velocity of omega. You know that velocity of B with respect to A will be given like this. So velocity of B with respect to A is AB into omega AB, and direction will be in sense of omega. If omega is going like this, direction will be this. What would be the right answer, guys? Sachin, Bhavya, Pavan, Midun, Ramesh Mohan, Anurag, Bhanu. Okay. So guys, magnitude of the linear velocity of any point on the kinematic link relative to the other point. So it is given as V is equals to R omega. So product of angular velocity of the link and distance between them. D is correct. I don't know why you are saying A. I don't know why you are saying A as the answer. Question number 14, guys. वेरी गुड नवीन, वेरी गुड भाई, बहुत ही बढ़िया, वंडरफुल गाइस. So do like and share the session guys. Only 14th question we are reaching to till now. This session will go up to 7:30, you know that. And if some questions are pending, we will be covering in the next class. Those you can try as the homework. Okay. Yes. Yes. Manas is saying D. हाँ, तो ओमेगा सेम होगा अनुराग. ओमेगा will be same. Linear velocity will not be same. In case of rotation, angular velocity is same. Linear velocity is not same. बहुत ही बढ़िया भाई. So majority of you are saying the answer to be C. Let us see. So they are saying velocity of point D and velocity of point E. So my dear, you know that this is the case of pure rolling. This is the case of pure rolling. There are three types of things. One is pure translation, one is pure rotation, and third is pure rolling. Just consider this body, my dear. If this body is directly translating like this without having any rotation, that motion is pure translation. Okay. If this body is rotating at its own point, means the center of the rotation is fixed. This is said to be pure rotation. And if you see the motion of the wheel of your car on the road, it is like pure rolling. So my dear, pure translation, pure rotation, and pure rolling. Anurag, now the answer to your question will be coming. I will say if some body is in pure translation, then my dear, velocity of all the point is same. If you are saying translating with 5 meters per second, then my dear, velocity of all the points is going to be 5. Like this. This is said to be pure translation. My dear, there is second motion, that is pure rotation. In pure rotation, omega of all the points on the body is same, but velocity varies with the radius. You know that? Velocity will be increasing like this. Like this. You may have this as 5, 3, 2, 0, minus 1, minus 3. So this is plus 3, plus 1, 0, minus 3, sorry, minus 3, minus 5. This is pure rotation, my dear. Very good, Anurag. This is pure rotation. So my dear, whenever you want to combine it in such a way, you are saying that pure rolling motion. Then my dear, in pure rolling, the condition is you will be giving a rotation of omega to the body, but after giving this rotation, the point of contact will be having 0 velocity. So my dear, you are providing some angular velocity omega, but you are saying velocity of this point of contact is 0. So how it is possible? You know, because of rotation, this will be having the velocity profile like this. Okay, this is 5, this is minus 5. And my dear, you want to say that after giving omega, this minus 5 will become 0. This minus 5 can become 0 if you add into this plus 5. So to add it in plus 5, I am giving a pure translation of 5. So if I will be giving a pure translation of 5, then the overall motion will become like this. You know, this is 5, this is 5, this will become 10. At center, this is 0, this is 5, this will become 5. At this point, it is minus 5, it is plus 5, this will be 0. So this is the velocity profile for the pure rolling motion. Is it clear, guys? हाँ, ये वहीं से आया है, ठीक है? It is from engineering mechanics, guys. So guys, when we are talking about this, the question is of same type only. If you want to find out velocity of any point, just do one thing. This point D will be having velocity of Vc because of translation, velocity of Vc because of rotation. So both of them will give you 2Vc. So 2Vc is the velocity of D. It is there in option A and option C. So B and D cannot be correct. But if you see the point E, This translation velocity is same for every point. Rotation velocity is always perpendicular to the radius. So this is VC here, VC here. If you go for the resultant, it will be root 2 VC. So the velocity of E is root 2 VC. So C is the correct answer. C is the correct answer. So everybody got it? Jishnu, you understood or not? So I have briefly explained the concept. If you find proper explanation, just inform me. I will go for it. Okay, like in the previous question you guys said, I have gone through that. Yes, Jishnu. So this is the question from relative velocity approach. Relative velocity approach. Very good, very good. So if you find, yes, Sachin, are you there or not? Sachin Gautam. Whenever you find, sir, I didn't understand with this explanation, just inform me. I will go for detailed explanation. Okay. Because that was related to engineering mechanics, so I didn't discuss it in more detail. Okay, Piyush ji, Pawan, Manas, Bhavya. This is very easy question. Yes, good Sachin. So dear, whenever you find difficulty, do ask me. I am always there to help you. Okay. कविराज बहुत बढ़िया, प्रांजल बहुत बढ़िया, जिष्णु बहुत बढ़िया. So guys, whenever you see this type of question, what is the identification of this? Identification is input and output links are parallel to each other. So when input and output links are parallel to each other, my dear, you can write velocity of B with respect to A coming out to be equals to velocity of C with respect to D. Whenever you get links to be parallel, parallel doesn't mean 90-degree angle. Parallel can be like this also. Whenever they are parallel, the velocity of this point with respect to this, velocity of this with respect to this are going to be equal. You can write, this can be derived by velocity diagram, but no need to go for it. This is, you can directly use it. I have done it in the classes. AB into omega 2, you can write it. And this can be written as CD into omega 4. They have already mentioned in the mechanism link 2 is having a velocity of 10 radian per second. Omega 2 is 10. And they are also mentioning AB to be 100. CD is also given as 180 omega 4. So omega 4 will be coming out to be 5.5 radians per second. B is the right answer. Very good, Ramesh Mohan, Sachin, Bhanu, bahut hi badhiya. Coriolis component of acceleration. Guys, do like and share the session. We are still left with many problems. Still 20 minutes class is pending. Next question. Yes, Anurag, you are correct. They are asking you which of the following is giving wrong answer for Coriolis component. Yes. So guys, the question which we are unable to cover today from this PDF, we are going to cover tomorrow. So would you like to try them for yourself? Then I will be providing you this PDF after the session to my Telegram channel. Okay. So if you do it, it's fine. If you don't do it, then also fine. Tomorrow I will be doing in the class. Jishnu is saying B. Jishnu is saying B. Manas, Ashrit. Sure, Piyush. Sure, Piyush. So guys, answer for this is A. So my dear, first of all, you must be aware that Coriolis component is always coming for the slider motion. The slider which is sliding on a link which is already in rotation. So you can see in all the cases links are in rotation. So Coriolis component will come for the slider. And the magnitude is 2v omega, that is also true. Direction, if you want to see, my dear, direction is nothing but if you are rotating the velocity vector by 90 degree in the sense of rotation of omega. Like for this case, sense of rotation is clockwise. Velocity direction is this. If you imagine a clock here, the time is 6. If you will rotate clockwise by 90 degree, time will become 9. So this would be the direction of Coriolis, but they have given this, so this is wrong. So this is 1, 2, 3, 4. It means fourth one is wrong. So only this option consists of fourth one. A would be the right answer. If you see this one, this is clockwise. Velocity is given in this way. Time is 12. After 90 degree clockwise, time will be 3. So direction is correct. It is right. Here if you see, this is the direction. This is anti-clockwise. So if you imagine a clock here, clockwise will make it here, but it is anti-clockwise, so we'll go here. So given direction is this, so it is wrong. So 2 and 4 are the wrong directions. Yes. Fine, Teju. Question number 17, guys. We are still left. I feel more than 20 questions we will solve out of 33. Okay. So we will be left with only hardly 5-7 questions. For the position of link goes on changing, the center about which the motion is assumed to take place will be the center which goes on changing from one instant to other, the locus of all I centers, the locus of I axis, none of these. Yes, guys, solve it, solve it. Jishnu B, Pawan B. Okay. Dear, for the position of a link goes on changing, the center about which the motion is assumed to take place will be. Yes. Anurag, I am telling you, they are saying if there is a link AB, they are saying for the position of a link goes on changing. If the position of this link is changing throughout, then the center about which the motion is assumed to be pure rotation. They are saying the center about which the motion is assumed to be pure rotation. उस center का नाम क्या है? What is the name of that center? Then in the option they are saying the center which goes on changing from one instant to other, the locus of all I centers. Then they are saying the locus of I axis, none of these. So guys, first of all, it cannot be C and D. The confusion should be between A and B only. So my dear, they are saying that for the position of filling goes on changing, the center about which the motion is assumed to take place. So they are talking about only that center. They are not talking about the motion of that center. So motion of that center is the locus of I center. So this is not correct. They are talking about the point. So the center which goes on changing from one instant to other. So if link is changing, the point is also changing. That is I center of rotation. Okay, A is the answer. It was slightly confusing, no doubt. A link AB is moving in a vertical plane at a certain instant when the link is inclined to 60 degree. The point B is moving vertically upward with a velocity of 2.9 meter per second. A is moving horizontally. Velocity of B at that instant would be. You need to answer this one. And velocity of okay, I feel velocity of B is given. A is okay, velocity of B is given. Velocity of A is asked. Solve it, guys. This type of question we have already done. Nothing new. Dear, locus of eye center is known as centroid. Locus of eye axis is known as axod. Centroid is the locus of eye centers. Axod is the locus of eye axis. Okay, Anurag. Locus means path. Kaviraj, Teju, Bhavya, Anurag, Bhanu, Pranjal, Nikhil, Jishnu, Ramesh Mohan, very good. Ramesh Mohan is saying C. Fine. So you can write VB, BI into omega. VA, AI into omega. नहीं, hard नहीं है. Centroid and axod, they are not hard. Why it is hard? It is very easy. Center motion, centroid, axis motion, axod. Just add ode behind the name. Very good, Bhavya. The answer for this C is correct. So dear, you need to find out velocity of A. Velocity of B is 2.9. So this will be written as AI into omega is 2.9 by BI. So this angle is 60. So AI by BI is tangent 60. Tangent 60 is root 3. C is the answer. Very good, guys. Question number 19. This is once again confusing question. You can expect this in GATE. GATE have already asked one similar question. Okay, similar question they have asked. Very good, Anurag. Nahi, Anurag. That is useful in theory only for HPCL, engineering services, civil services, ISRO, DRDO, BARC. Not for GATE. This question, this type of question have already been there in the GATE. Okay, they have asked for rolling pair. I am asking you for a normal link. In GATE, they have asked for pure rolling motion. I am asking you for general motion. That is the only difference. Pavan Kalyan is saying A. Okay, what about others? Bhanu Teja is saying A. Teju is saying A. बहुत बढ़िया, बहुत बढ़िया. Anurag is saying B. Piyush ji A. बहुत बढ़िया. So my dear, you must be aware, whenever we are talking about the radial acceleration or centripetal acceleration, it is given as omega square r. Whenever we are talking about tangential acceleration, it is like that, r cross alpha or alpha cross r. Okay. Okay. So if you want to find out net acceleration, then it is A radial vector plus A tangential vector. In that way, you can write it as omega square plus alpha cross r. But if you will be writing the magnitude of this, it is square root of omega square r का square r alpha का square. AB outside, this is omega square plus alpha square. So this is correct for magnitude. The answer for this is going to be B, not A. A is the magnitude. Is it clear, guys? Yes. So Bhanu, it is not as direct as you were feeling. Okay. So it was not as direct as you were feeling. Magnitude is not mentioned. That's why I am saying this is the answer. If they would be writing magnitude, then A would be the answer. Okay. So answer is this only. They are vectors. Anurag, very good. Fine. Are you getting Manas, Jishnu, Pranjal, Piyush, Kaviraj, Teju? So A is correct if they are asking about magnitude. B is correct in general. Okay. This is very easy question. I know all of you will be giving the right answer for this. Teju, are you clear or not? Bhanu, are you clear or not? हाँ, वो होना चाहिए जिष्णु, वो होना चाहिए, आपकी बात सही है, बट दे हैव नॉट मेंशन मैग्नीट्यूड वर्ड आल्सो इन द क्वेश्चन. ओके, वेरी गुड पवन, भारत, मानस, भव्या, भानु तेजा, बहुत ही बढ़िया. जिष्णु, मिथुन, सचिन, कहां है सचिन, प्रांजल, वेरी गुड. So the answer for this will be B. This is simply velocity of A. This type of question have been there in ESC. Very good, Sachin. GATE, they have not asked this one. Klintz construction. Klintz construction. Yes, guys. Very good. So we are still left with 8 minutes. I feel 2-3 more questions will be over. Very good, Bharat, Teju, Pranjal, Ashrit, Sachin. Bharat, try to join daily at 6 p.m. Okay, all of you guys, tomorrow 6 p.m. you need to join. Tomorrow 6 p.m. you need to join. Tomorrow's topic is flywheel and kinematic and dynamic analysis of single slider crank mechanism. Today's 6 to 7 pending question would also be solved in tomorrow's class at the end. Okay. Yes. Mentos Zindagi. Bhanu, yaad hai dialogue. Klintz construction is mainly used for. This is used for linear acceleration of the piston mainly. Okay, guys. Because velocity analysis is very easy, we can directly go for it. So majorly we are talking about acceleration when we are talking about Klintz construction. Yes. कोई बात नहीं प्रांजल, easy लगेगा, एक बार पढ़ लोगे सही से. So dear, what is there in you can say whenever we are talking about Klintz Klintz construction, it is given for single slider crank mechanism. This is for single slider crank mechanism. Okay, I am telling you the procedure, don't worry. So my dear, just feel it. This is rotating with some angular velocity of omega. So Klein's construction was given to find out velocity and acceleration analysis without plotting the velocity acceleration diagram. And also they are saying one thing, that for this alpha of crank should be 0. That is the condition we are assuming to apply the Klein's construction. If you want to go for velocity analysis or velocity diagram, the procedure is very simple. Plot a perpendicular to the line of stroke. Extend the connecting rod length. This is O, this is A, this is P. This triangle OAP is the velocity triangle, which is 90 degree oriented with a scale factor of omega. This was the first diagram given by the Klein's construction. Then my dear, if you want to go for the acceleration diagram, plot a circle by taking AB as radius. Taking AP as radius, make a circle. Taking AB as diameter, plot another circle. Wherever two circles are intersecting each other, join those 2 points. Whenever you are joining these 2 points, my dear, extend it to the line of stroke. Now, if you can feel, I am showing you a quadrilateral OA, and let us say this is Q, this is R. So this OAQR, quadrilateral OAQR, this quadrilateral is the acceleration diagram with 180 degree orientation and omega square scale factor. These are velocity and acceleration analysis. So in the classes when I was teaching you, I have also made velocity and acceleration diagram with normal rules. Then I have also verified these points with you. So here I am directly telling you, there we have verified that. Okay. So because verification is not required, that I have done just to give you a feel of that. Okay. In LTQ, these are the enough requirement for the question. Is it clear? Very good Teju, very good. Pawan, actually yesterday I was outside somewhere, so that's why class was not there, but don't worry. We are starting from today and we will go till Sunday as per the requirement. So the answer for this is B, no doubt. I feel you understood this. If you understood this properly, I am also telling you that here OA will give you acceleration of crank. Here AQ will give you acceleration of connecting rod. And QR will also give you acceleration of connecting rod, because connecting rod will be having radial and tangential both. Then RO is giving you acceleration of slider. Okay, so this is how we have seen it. Okay, so if you want more detailed discussion of that, you can mention that topic in the comment section. I will be making a concept capsule for Coriolis component and Klein's construction. Concept capsule of this month I need to put still. So if you want more explanation for this, just write that in the comment section. I will be making a concept capsule which will be available on this channel in the recording format. I will explain it completely in 20-25 minutes. Okay, so don't worry about that. We are there to help you only, guys. Sure. So this month concept capsule will be having this topic. I can explain right now also, but time is about to end. Okay, fine. So this month concept capsule will be having this Klein's construction. Okay, so the given figure shows the Klein's construction for acceleration of slider crank mechanism. Which one of the following quadrilateral represent acceleration diagram? Yes. Which quadrilateral, dear? Which quadrilateral? Let us see how many of you will give the right answer for this. This is last question for today. This is last question for today. Yes, guys. Dear, first of all, this is crank. This is crank. Okay. One circle will be coming like this. Other circle will be coming like this. Sorry. Second circle will be going like this. Taking this as radius, na? Yes. बहुत बढ़िया. आश्रित आ गया. Very good. Anurag, Bhanu, OPST is correct. Dear OP, PS, ST. Okay, so actually the given figure is like that. I am unable to make circle properly. Okay, otherwise you understood. OPST. Okay guys, so this would be the extension actually. Two circles will be meeting here. This is the extension. OPST. Sachin, understood or not? So majority of you understood, I feel so. So guys, it's time to say goodbye. दिल तो नहीं चाहता, but समय समाप्ति की घोषणा हो चुकी है. So we need to say goodbye. So Bharat, as I feel you have joined late, so I would like to say join tomorrow at 6 p.m. First of all, we will see some new and good questions from kinematic and dynamic analysis, then from flywheel, and then the pending question of this session, because this PPT consists of 33 questions. We have done 22. 11 questions are pending. 5 we will do tomorrow. 5 we will do in the next session. So be ready for that. So goodbye guys for this session. Thanks for joining. Goodbye.